Hey everyone, in today's video we'll see about how k-fold cross-validation works. We're going to use a Streamlit app to split data, train a logistic regression model on each fold and visualize the results. Let's get started. Here's our simulator dashboard. On the left, we have got a sidebar with customizable settings. You can adjust the total number of data points, choose the number of features per sample, and set how many folds you want. You can also toggle a progress bar to watch the training unfold in real time. Under the hood, we use NumPy to generate random features and labels. Each row in the dataset represents a sample with randomly assigned binary class label 0 or 1. This gives us a simple classification problem to play with. We then use the k-fold class from scikit-learn to split the dataset into k-folds. Each fold acts as a test set, while the other k-1 folds are used for training. This ensures every data point gets evaluated and helps reduce overfitting. Now the exciting part. For each fold, we train a logistic regression model on the training data and evaluate it on the test. The predictions are compared with the actual labels to calculate accuracy, and this score is saved for that fold. We also show a clear visual of each fold using Matplot library. Blue bars represent training data, while orange bars highlight the test fold. This helps you see how cross-validation works across the entire dataset. As each fold finishes, you will see a progress bar update on the screen. We also display the test indices used and the accuracy score for that specific fold. Once all folds are complete, we calculate and display the mean accuracy across all k-folds. You also get a bar chart showing how your model performed on each fold. This gives you a solid sense of how well your model generalizes to unseen data. Technically, a k-fold evaluates machine learning models by splitting the dataset into k-folds, training the model k times on k-1 folds, and validating it on a remaining fold, averaging the results for a robust performance estimate. K-fold cross-validation helps accessing how well a model generalizes to unseen data by using different portions of the dataset for training and testing in multiple iterations. The process involves it divides the dataset by splitting k equal size subsets or folds. Then, for each iteration, one fold is used as a validation set and the remaining k- folds are used as a training set. Later, train the model on the training set and evaluate its performance on the validation set. Repeat the process k times ensures each fold is used as a validation set exactly once. For example, let's take 5-fold cross-validation. The dataset is split into 5 folds. The model is trained 5 times, each time using 4 folds for training and 1 fold for validation. At last, calculate the average of performance matrices across all k iterations to get an overall estimate of the model's performance. Benefits of having a k-fold cross-validation is it provides reliable estimation of model performance than a single train test split. And also, it reduces the risk of overfitting. Common values for k includes 5 and 10, and it basically best works for small set of data just because of its computation costs. So that's all for today. Thanks for watching.